Here it has been asked to find the equation of the perpendicular from the point which is 3 comma minus 1 comma 11 to the straight line. Here this is point A and this is the straight line which is having equation x by 2 equals to y minus 2 by 3 is equals to z minus 3 by 4. Then so here we have to find the equation of the perpendicular which is drawn from this point on this straight line AM. So we have to find the equation of AM, and we have to also find the coordinates of the foot of the perpendicular M. M is called the foot of the perpendicular from the point A, on the line. Okay. So we have to find the equation of AM also and the length of AM also. We have to find the equation of the perpendicular AM and the length AM also we have to find. So here we can see that this line L1, it is parallel to the vector. We can call it as B1 vector. So the direction ratios along the vector L1 is the straight line L1 is 2, 3, and 4. So B1 vector we can write it as 2i cap plus 3j cap plus 4k cap. So now since AM is perpendicular to the line L1, so we can say that the vector AM vector that will be also perpendicular to the vector B1. So therefore we can say that AM vector dot B1 vector that should be equal to 0. So now any point on the straight line L1 that can be found out by taking this equal to lambda, suppose. So then x will come as 2 lambda and y will come as 3 lambda plus 2 and z will come as 4 lambda plus 3. So therefore, the coordinates of the point M can be written as 2 lambda, 3 lambda plus 2 and 4, 4 lambda plus 3. So now the vector AM, the AM vector that can be written as 2 lambda minus 3 I cap plus 3 lambda plus 2 minus 1, so it is plus 1 G cap, then plus it is 4 lambda plus 3 minus 11 K cap. So this will be equal to 2 lambda minus 3 I cap plus 3 lambda plus 3 J cap plus 4 lambda minus 8 K cap. So now, therefore, we need to find AM vector dot B1 vector. That should be equal to 2 lambda minus 3 into B1 vector is this. So we will do into 2. Then plus 3 lambda plus 3. Then into this will be 3 plus 4 lambda minus 8 into this will be 4. So that should be equal to 0. So then we will get 4 lambda minus 6, then plus 9 lambda plus 9, then plus this is 16 lambda minus 32. So that should be equal to 0. It means that 4 lambda plus 16 lambda, so it is 20, so 29 lambda, that will be equal to 32 plus 6 minus 9. So then lambda will be equal to 38 minus 9 by 29. So then lambda will be equal to 29 by 29. So it is equal to 1. So therefore the point M can be written as 2 comma 3 plus 2, which is 5, comma 4 plus 3, which is 7. So M is 2, comma 5, comma 7. So this is the required foot of the perpendicular from the given point on the given straight line. So we need to find the length of this perpendicular and the equation of the perpendicular also. So the equation of the perpendicular, how to find? So now we need to find the direction ratios along the vector AM. So therefore now AM vector that will be equal to 2 lambda minus 3, so it is 2 minus 3 I cap, plus this is 3 lambda plus 3, so it is 6 j cap, plus 4 lambda is 4 minus 8, so that is minus 4 k cap. So this will be equal to minus I cap plus 6 j cap and minus 4 k cap. So this is AM vector. So therefore the vector AM, this is A, this is M. M is 2 comma 5 comma 7 and A is 3 comma minus 1 comma 11. Then so AM vector, so therefore AM vector is minus I cap plus 6 j cap minus 4 k cap. So if we have to find the equation of this AM, equation of this perpendicular AM, so therefore the equation of the perpendicular AM, so this will be is R vector equals to, this is 3 I cap minus j cap plus 11 k cap plus mu into, I can write minus I cap plus 6 j cap minus 4 k cap. So this is the vector equation of the perpendicular AM. If you want, we can find the Cartesian equation also. So therefore the Cartesian equation of the perpendicular on the line, that will be given as x minus 3 by minus 1, that is equal to y plus 1 by 6, and that is equal to z minus 11 by minus 4. So this is the required Cartesian equation of the perpendicular on the straight line. And we need to find the length of the perpendicular also. It means we have to find mod of AM, which is the length. So that is square root of 2 minus 3 whole square plus 5 plus 1 whole square plus this is 7 minus 11 whole square. So that will be equal to square root of 1 square plus 6 square plus 4 square. So this will be equal to square root of 1 plus 36 plus 16. So this will be equal to 17 plus 36. So this will be 7 to the 14, 13, 3, 4, 5. So this is square root of 53 units. Therefore, the final answers we can write that the equation of the perpendicular, first we have to find the equation of the perpendicular is x minus 3 by minus 1, that is equals to y plus 1 by 6, that is equals to z minus 11 by minus 4. And the length of the perpendicular is root over 53 units, and the coordinates of the foot and the coordinates of the foot of the perpendicular is 2 comma 5 comma 7. So this is the final answer. Thank you.